what we're doing today, okay, is a lab that's very much like the speed and radius lab that we did last week, okay, except this time we're changing it up. We're not looking at the effect of radius on speed. Now we're looking at the effect of centripetal force on speed. So all we're doing is changing the manipulated variable here. Okay, in our last lab, it was radius. Now it's going to be centripetal force. Spoiler alert, I just gave you one of them. Okay? Yeah. And, okay, we're going to be looking at the effect of centripetal force on speed. Now that means that we have to keep a fair amount of other things that can also affect speed the same. They would be the other control variables from your last lab. Okay? So the variables in this lab are the radius of the circular path, okay, the mass of the rubber stopper, okay, the mass of the hanging mass that's providing our centripetal force, by the way, okay, the number of revolutions, the elapsed time, the period, and the speed. Okay, remember in our last lab we actually had to time the elapsed time, use that to calculate the period, and then we use the period and the radius to calculate the speed. Now that doesn't mean that not a lot of things are changing. You actually do have several responding variables here, okay? Because we are not measuring the speed directly. Okay? We can't. So we have to time it, use the elapsed time to get the period, use the period to get the speed. So all three of those things are changing, okay, throughout the lab. Okay. For our hypothesis here, okay, very similar to our last lab, okay, we want an if, and then statement, okay, where the if part is going to tell me the relationship, okay, between centripetal force and speed. Now, something to keep in mind, this is different than the relationship between speed and centripetal force. Because we've talked about that relationship a whole bunch. Okay? Remember that in this formula, V is squared. If I change V, Fc goes up exponentially. But it isn't true the other way around. Okay? If we change Fc, it does have an effect on V, obviously, okay? But that effect is not exponential. Okay? It's okay if you don't get it right in your hypothesis. You just have to get it right in your conclusion. Right? And I'm just looking for something general here. Okay? Not looking for anything like super specific, like, you know, it's you know, quadratic or anything like that. Okay? All right. So that's for the if part. Okay, the and part's going to describe the experiment. So the rubber stopper is going to be whirled in a circle of fixed radius with changing centripetal force. Okay, and then the then part. Okay, I want your prediction, same as I did for the last one. Okay, predict the effect. Okay, of Fc on V. Okay, what's going to happen to V as we increase Fc, just prediction there. Okay, so good news. The procedure is pretty much the same as the last time. So if somebody in your group was getting really good at twirling the rubber stopper, they should keep that job. If they sucked at it, they should be fired and someone else should do it. Okay? But if they were getting good at it, let them do it again because they've got practice. Okay? So all we're doing in this one, okay, like I said, the procedure is pretty much the same. All we're doing is changing the hanging mass, because by changing the hanging mass, we're changing the amount of gravitational force that's pulling on the rubber stopper. Okay? And it's that gravitational force that is acting as a centripetal force. So by changing the mass, okay, we are changing the centripetal force, and hopefully that's going to have some effect on the time for 20 revolutions, okay, the period, and the speed. Right? Now, our centripetal force, remember, is being provided by gravity, which means, okay, we calculate that by m times g. It's not a difficult calculation. One thing you have to watch, the masses are in what units? Grams. What do you need them to be in? Kilograms. Keep that in mind when you do that calculation. Okay? So all you're going to do, okay, is you're going to use the masses that are prescribed here. Okay? You're going to increase the hanging mass by 50 grams on each one, and does it say in yours which one to start with? Yeah, attach a 50-gram mass to it. So you're going to start out with 50 grams, okay, and go up by 50 grams each time. So 50, so 0.05, 0.1, 0.15, 0.2, 0.250. Do not go any higher than that, okay, because you have to go super fast, okay, and it starts to become a little less controllable. Okay, when we start getting that. Okay, they are also telling you that your fixed radius is going to be 40 centimeters. I saw that somewhere right here. Okay, so your radius for each one is 40 centimeters. You only have to put one mark on the string this time and keep it there. Okay, and your recording same as last time. So time 20 revolutions, twice for each mass. Get your average time. Divide that by 20 to get your period. Okay, and then use V equals 2 pi r over t to get your speed, okay, and all that. That's all in the analysis, okay. So on the next page here for each trial, average of 2 times, okay. So do those calculations. Question number 4, okay. So question 5 is wanting you to plot a graph of speed versus centripetal force, okay, and use a polynomial fit line for that, okay, because sometimes on people's it doesn't look like it should be curved, but it is, okay, and people put a linear fit by mistake. Okay, so a polynomial fit line on that one. Okay, remember to plot the manipulated variable on the horizontal axis, responding on the vertical axis. Okay, and then for number 6, talk about the relationship between centripetal force, why it's not linear. Okay, describe the relationship without naming it. Okay, you don't need to tell me it's polynomial or quadratic or whatever. Okay, just describe it. Okay. Explain why it's not linear. Conclusion and evaluation, same as always. Okay, restate your hypothesis, explain why you can accept or reject it. 2 sources of error, probably the same sources of error as the last lab, since the procedure is pretty much the same. Okay. All right, so there's really not a lot to do for the analysis. You have like a graph and 1 question to really answer. Okay, the rest, for any ones that involve a calculation, please just show me 1 example of that calculation. You don't need to show me all of them, just 1. So if you get some weird numbers, I can go back and see why. Okay. Questions?
Can you show 1 trial?
Yeah, just for 1 trial. Like, so for question number 2, show, you know, for trial 1 that you divided the average time by 20. Right? Just show me that calculation and so on and so on. Okay. Any other questions on what we're doing? Okay, remember that when you're done, okay, there's sanitizer on the cart, on both carts up here. Please make sure you spray down anything you touched with it. Okay, you don't necessarily need to wipe it down after. Just give it a good spraying. The alcohol will evaporate and sterilize everything supposedly. Okay. All right. If there are no questions, okay, then you have the entire period to work on this, and that will allow you, I think, to get it pretty much done and maybe even have some time to work on the other one. Okay. So let's get the data collected, okay, to get that all together here.